Ever feel a bit cold, perhaps on a winter night? Now think about space. Usually we imagine fire, sun, stars, blazing hot. But hold that thought. There are objects out there vastly cooler than expected. Some, believe it or not, are colder than you. Yes, you heard that right. Celestial bodies way out there, colder than human beings. Your average body temperature? Around 37 degrees Celsius, or 98.6 Fahrenheit. These cosmic entities? Some are cooler, much cooler. It's a strange thought, isn't it? A star-like thing, so very chill. We call these objects brown dwarfs. A curious name, perhaps. They are not quite stars, they are not quite planets. They exist in a cosmic middle, a fascinating in-between state. Think of them as celestial misfits, or maybe cosmic underachievers. But cool ones, literally. So what gives? Why are these brown dwarfs so surprisingly lukewarm or cold? It's all about their beginnings, their mass, their internal fire. Or rather, the lack of it. They are the universe's slow burners, fading embers in the dark. Let's explore these chilly giants. The universe is full of surprises. What exactly is a brown dwarf? Imagine a star trying to be born. It gathers gas and dust, hydrogen, helium, the usual stuff. It needs to get big, and really dense, enough to ignite its core to start nuclear fusion. That's the star-making recipe, but sometimes it falls short. Brown dwarfs are these strivers. They just don't accumulate enough material, enough mass. They are bigger than planets. Much bigger than Jupiter, our giant. Think 13 to 80 Jupiters. That's a lot of gas. But they are smaller than the smallest true stars, not quite hefty enough. Their composition is star-like, mostly hydrogen, some helium, just like our sun or any star. This is what they're made of. But the spark is missing, the immense pressure, the extreme heat at the core needed for sustained hydrogen fusion, that glorious star-powering burn. They just can't keep it going. So they are often called failed stars. A bit harsh? Maybe substellar objects is kinder. They do manage some fusion. For a short while, early on, they can fuse deuterium, a heavier type of hydrogen. But this phase is brief. It doesn't last like a star's fire. Then they just cool down. Forever. Let's talk temperature again. It's what makes brown dwarfs so uniquely interesting. Some are relatively warm, true, thousands of degrees Celsius, hotter than your oven for sure, but many are much cooler, especially the older ones. They just keep losing heat. Slowly, steadily they fade. The coolest ones we found? These are the Y-type dwarfs. Their surfaces can be incredibly cold. Some are around room temperature. Imagine a celestial object as cool as a pleasant spring day, or even colder still. Some dip below freezing, colder than your freezer, colder than a human. Amazing. Why so cool, you ask? It's that lack of fusion. True stars burn hydrogen. This process releases enormous energy. It keeps them hot for billions of years. Brown dwarfs can't do this. Their deuterium fusion is a flicker, not a sustained blaze. So, they radiate their birth heat. And then, they just cool and cool. Their atmospheres are wild. Because they are so cool, things can condense there. Not just water clouds like Earth. Think clouds of molten rock, silicates, iron, even salts, swirling in their dim skies. Imagine floating through that. Exotic weather on a cosmic scale, possible only at these low temperatures. Oh. Discovering brown dwarfs wasn't easy. They were theorized for decades. Shiv Kumar first predicted them in the 1960s. But finding them? That was tough. They are incredibly faint. They don't shine brightly like stars. They emit most of their light, not as visible light we see, but in the infrared spectrum, heat radiation essentially. So how do we spot them? We need special eyes, powerful infrared telescopes. Think of them as cosmic heat seekers, like Spitzer Space Telescope or the WISE mission. They scan the skies for faint glows, the telltale signature of a brown dwarf. It's like looking for a dim ember in a vast dark forest, a challenging cosmic hunt. Why do these cool characters matter? They are a crucial link. They bridge the gap in our knowledge between giant gas planets like Jupiter and the smallest, dimmest stars. They help us understand formation. How stars are born, how planets form. Are they born like stars from collapsing clouds, or like planets from disks around stars? The answer is probably both. Brown dwarfs are common too. There could be billions of them lurking in our Milky Way galaxy. Some float alone in space, rogue brown dwarfs unbound. Others orbit stars like planets. They are part of the cosmic fabric, teaching us about diversity. The universe isn't just hot stars, it's full of these fascinating, cooler objects. Still much to learn, always.